Hello everyone, and let's continue with module 5, network design and planning. And in this video we are going to look at the case study. So uh, we are going to design a network for the college. So let me just take you through the case study question. Consider a new upcoming college with a similar building structure as ours. Uh, Design the setup of computers for. So basically, we have to construct a computer, or rather, create a network design for computer labs. So there are mechanical department, electronics and telecommunication, computer and IT department. But this is a college, a hypothetical college, which we are talking about in this case study, is a college which is just starting. So if a college is just starting, engineering college just starting, you will have in the first year of the college as only the FEs will be there, right? Since the college is just starting. Second year may you will have this FEs going to SE, and you will have SE and FE. Then you will have this SEs going to T, then you will have TE, SE and FE. So each year will progressively go on starting. Uh, so this is a new college. Now what we have to assume, let's read through that. Assume the setup is to grow stage wise as the students are admitted. That means I'm not building the entire network for 4 years in the first year itself, which is obviously true, because you don't want that investment to lie redundant till the students come to those years, right? So that is, the setup has to be ready for FE in the first year and for FE plus SE in the second year. Assume currently we are planning for only 2 years. Okay, because if we start doing this for entire 4 years, it will be a very large, big question, and it will be very time consuming to solve. So we are going to focus only for 2 years. So which means we are having FEs and we are having SEs. Also consider server room which connects the campus to the internet. Okay, so draw a 2-year plan stage wise setup of the network with appropriate consideration of scalability, performance and redundancy. So based on these 3 parameters, we have to see how we are going to design the network for this college. Now in such a kind of a design problem, we have to first start with the set of design considerations. How many computers are we going to require, because that is what is basically going to help us understand how the structuring of the network or how the designing of the network will be. So let's first understand, of course some of this data is from what we are doing currently in college, and some of this is a pretty hypothetical data. So you can very well assume a hypothetical data, no problem, because you are basically looking at what is the number of PCs. So for the first year, how many number of computers will be required? I have assumed that there is a department office in which there are 2 computers, which means 2 IP addresses will be required there. There is a computer center which is having 30 computers. There is a language lab with 20 computers, and a staff room where there are 9 faculties, let us say. So this 9 faculty will be requiring 9 machines, and therefore 9 IP address. Now this is the situation that you will have in the first year. So in the first year you would have a very small network, that is 50, roughly 61 machines, right? In the second year you will be having a computer engineering branch, IT branch, EXTC branch and mechanical branch. So let us say that the number of labs that would be required, of course this number of labs also can increase year wise, but I am saying that right now we are building all the 6 labs. So 6 labs into 20 machines, that means you will have 120 computers. Staff room there are, let us say, 24 to 27 staff, and department office there are 6 PCs. Similarly, there are certain assumptions that we are making for each of the department. Okay, Now these are the numbers which are you can very well hypothetically assume. So no hard and fast figure. If somebody says, okay, my computer center is going to have 20 PCs, fine, but generally you don't have a batch size less than 20. So minimum number of computers in a lab will essentially be 20. Okay. Now, what are the design considerations that we would be looking at from the scalability, performance, and redundancy point of view? The first thing that we are going to look at is we need to have some extra IP addresses, because we may be requiring expansion happening in each of the labs. So for each of the labs, I need to provide some set of IP addresses which can be allocated in future. Another thing that we need to also take care of it is in the lab in future we may have to make a provision of wireless connectivity. That is, the students may bring in laptops and there will be a wireless connectivity which is allowed. So in such case also I need to keep certain IP addresses available. Okay. The second, so that is what was our second point, that is laptop may need to connect to the internet. The staff require connectivity to the internet, so the department office and the staff room, we need to be able to connect those to the internet. Availability of the network in lab and staff room is not critical. Okay, which means that I need not design a network with redundancy for lab and staff room. When I say it is not critical, that means I don't require redundancy. But the department office, it is critical. Okay, now in department office, it is critical, and therefore network connectivity department office would require, and I require some kind of redundancy in that. Redundancy for the department office for internet connectivity is required. So that means fine, internal network it may lose connectivity for some time, it's okay, but internet connectivity for some reason happens to be important. Now these are all the assumptions, design assumptions that we have done. Based on this, we need to start with the design. The step one is you need to select the network architecture. Now we are having two options that we have studied. The first is the 3-tier architecture and the second is the 2-tier architecture. Now in the campus, which is similar to ours, it is not a huge campus. Roughly you will have around 1500 PCs, which is not a big network. So in such a case, a collapsed core campus network should be a decent thing. So what we are going to do is we are going to use here a collapsed core campus network architecture. Okay, so that is our first point. We need to decide which network architecture we are going to use. Now once we have decided that, we start building up the simple most layer, that is the access layer design. So now access layer, if you go back to whatever numbers we had assumed, for each of this you will have a separate access layer network diagram coming in. But let's understand, if this is a question that comes in the examination, it is going to be pretty difficult for each and every lab access layer design to be drawn. Alright, so as a sample you can choose one and you can draw the access layer network design for that. So here in this case I have drawn it for the computer center with 30 machines. So let's have a look at that. So this is 30 PCs connected to a Cisco 48 port switch. Now there are 30 PCs and a 48 port switch, which means I have an capability of expansion within the switch itself. So there are 18 ports in the switch which are unused. So here you can see the port number 31 to port number 48 are available. So here in this case, if I want to increase the number of PCs in the lab, there is a possibility of directly increasing 18 PCs without changing or making even a slightest change in the network. Okay. Now when we design the IP address scheme, which we will be designing a bit later, because first we will start with the hardware design and then we will go to the IP address design. So when we design the IP address scheme, we have to keep certain extra IP addresses. If we don't keep, and how much extra IP addresses? Minimum 18 I have to keep. Why minimum 18? Because already I have an 18 ports here available, which means if I have 18 IP addresses, I can just plug and play and start. I don't need to make any changes within the network itself. So this is where you are taking care of scalability of the network. Okay. So here there are different workstations, and each workstation is connected on which port number that is being specified here. What kind of a cable that is being used for communication? We are using Cat6 Ethernet cable connection, which is predominantly being used nowadays, and that's basically your access layer design. The similar to this, all your lab designs would be there. Only thing is, what might change is the switch with number of ports. How many ports switch you are going to use, that is a decision which has to, a design decision which has to happen. So that will change, as well as the number of machines and the layout, of course, of your network diagram will change. Okay. Now let's move to the next. So you're not going to show the access layer design for each and everything. Now let's come to the core and distribution layer, because it's a collapsed core that we are talking about. Let's understand one thing, that whenever your network is expanding, the access layer design can happen later. That is, when my college is increasing in the strength of students, number of students, first year के students है, then I have the second year students, then I have third year of my college going on, where I have T, SEs and FEs. So in that case, my access layer will keep on increasing every year. But can I create core and distribution layer later on? No. So my core and distribution layer has to be designed in such a way that it takes care of the data traffic that will be generated when entire 4 years are functional. Okay. So why collapsed core here? One of the reason is because you want to keep the cost less. Okay. And you're going to design now the entire core and distribution architecture together. Now, so let's come to the distribution architecture, but before that we'll have to just visit this. Okay, now if you look at this, you have first year. If you can just imagine our building, everything of this first year, let us assume that is on the ground floor. Everything of this of the computer engineering is on the second floor. So if this is the kind of a setup that you are looking at, then you can imagine of a distribution layer something like this. So you have two buildings, building A, where there are all the labs, and there are building B, where there are some of the labs. So you have EXTC and mechanical labs which are there in building B, and you have FE, comms and IT. We are assuming that each floor is allocated to each department, and therefore the labs are in that fashion. So this 6 labs of IT, 6 labs of computers, a computer center of 30 and language lab of 20. These labs are in building A. Now I need to connect this to the a switch which acts as my distribution layer. See, we are saying it is a collapsed core, but ऐसा नहीं है that we are going to skip the complete distribution design. The distribution design will get integrated strongly with the core. Okay, so here also the distribution design is getting strongly integrated with the core, which means the certain part of security policy might be implemented on this FE level aggregator switch, and certain part of security policy will be implemented on the core switch. Okay, so now the way it is happening is we are having an aggregator switch which is connected to this distribution switch for computer. For each department there is a distribution switch. Okay, now each of this distribution switch is directly, my offices are directly connected onto this distribution switches. Okay, my labs are connected onto this aggregation switch, and my office is also connected onto this distribution switch. My labs are getting connected here. Now the redundancy is required is only for the office. Okay, so my department office is connected here. Okay, office. Okay, I'm just trying to now department office is connected here. Now let's understand is that suppose if this network device or this aggregator switch fails, what happens? Is my department device still connected? Department office still connected? Yes, my department office is still connected. All my labs of FE will go away. In this case, they will not be able to access anything on the network. But anyway, we don't require redundancy there. Now, let us say for some reason this is my FE department office, and say this FE department office which is connected, if this link fails, now you see that there are two lines here, two red lines connecting. Okay, this means the switch is connected to the core with a backup link. So suppose if my primary link fails, automatically my secondary link will be active. Now we are not adding a device level redundancy here, but we are adding a link level redundancy. Okay, now coming to the core part of it. So the core switches are high speed switches, and this core switches are connected to something called as an edge router. The edge routers are connected to the internet. Now we said that we want a backup link for the internet, so there are, let us say, two routers which are connected to this internet. So if this router fails for some reason, there is a redundancy through this router. Okay, so if router 1 fails, router 2 takes over, and your internet connectivity is still available and still accessible. Okay, this core switches are connected to each other also. The core switches are connected to each other, and this core switches are also connected with the different aggregator switches. Okay, like right now if you see this switch, this is connected to core switch 2, and with this link it is connected to core switch 1 also. Okay, now what does this mean? Suppose if my core switch 1 fails, still this switch will be able to communicate via to the internet via the core switch 2. So if switch 1 fails, switch 2 takes over, and automatically it will work fine. Okay, so the redundancy is properly taken care of. The whole idea of designing the core and distribution layer is that how you're planning redundancy. So in this, what is important is how you're looking at redundancy. Okay, so this is the important part in this. Now let's look at so this is my collapsed core architecture, this is my access layer architecture, and now what I need to do is I need to look at IPv4 addressing allocation table. So you need to create something like this table where there is a location identified and the number of machines that are identified, what subnet you are going to use, and what is the start address and end address, which are usable IPs, because you know that the first address is the network address and the last address is the broadcast address when you create a subnet. So obviously those two addresses go away. Okay, now in FE Office I require 11 machines. Okay, FE Office 11 machines. Now why 11 machines? Let's have a look at this. Okay, so what has happened here is we have combined this two. Okay, now why we combined this two? See, the problem is in department office we have only 2 machines. Now the cost of providing connectivity and redundancy to this 2 machine is same as cost of providing redundancy to 9 machines. The reason is we get a switch which is of 16 port. Okay, so might as well I'll combine these two. So chalo, faculty will also get the benefit of the redundancy and they will also be able to access the internet. Okay, so this is how we have to look at a trade-off in terms of the cost and the usefulness. Okay, so though the staff room was not supposed to be covered under redundancy, but just because this number of PCs are too small and I can very well cover it with instead of using an 8 port switch, I can very well cover it using a 16 port switch, because the cost of 8 port and 16 port switch is fractionally high. It's not very high. So this investment becomes justified because I am giving an benefit of redundancy to the more people. So that's the whole idea. So this is how 9 plus 2 is equal to 11 is what we have got here. So this is my 11 machine. Now if my intake increases, what happens? My number of students will increase, my number of faculty will increase, and my number of department office people will increase. So automatically this host count will go up. So the subnet that I am using here is 10.10.10.0/24, which means my subnet mask is 255.255.255.0. Now if I look at it from a very layman's perspective, what it means is your last digit here is indicating 8 bits, right? So totally 254 machines will be there which are available. So my starting IP will be from 10.10.10.1 to 10.10.10.253. This will be my basically the usable IP address. So now you see here I require only 11, but how many IP addresses I am having? 253. So largely scalable, no problem here. Comms office, I am again having faculties plus the department office people to put together. Sorry. So I am having again here 253 IP addresses available. This is 10.10.20.0 network. I am using class C subnet mask. So that means the last digit here is going to vary from 0 to 255, and what is going to give me usable is 1 to 253. So again I am having 253 IP addresses, but 33 are going to be used. So same here. Now let's come to the labs. Okay, so let us say there are I think this is a mistake here, there's 6 labs. So there are 6 labs with 120 machines that are there. So I basically would require 120 IP addresses. Now I'm having this series 10.10.70.0. Now if you see, this is a setup which is very good from a route summarization point of view also. I can very easily do a route summarization on this because I am having a contiguous blocks of IP addresses being allocated. So it is not necessary that always you will have to use 192.168.10.1 or so on so IP address for small network. You can use 10K IP address also, and if you see that this is for various different machines that are scattered across the building A, building B, different departments, I'm using this IP address scheme. Now here, if you see, I am getting 253 total IP addresses, of which 120 are going to be used and remaining are still available with me. So this is a phenomenally scalable network that is there. Now in a server room, I am assuming that I am having two servers, but again I am keeping a range of 253 IP addresses, of which only two will be utilized. Now tomorrow if I have to add 10 more new servers, do I have the IP address? Yes. So similarly for the rest of the things. Now once you have the IP address allocation table ready, your answer for this design problem is done. Okay, so what basically you had done is, first we started with a question identifying what would be the total number of computers that would be required, and this is where you would be having some set of assumptions. So you need to specify this because based on this all your network design works. The second thing is, are there any design expectations or design considerations from scalability, performance and redundancy point of view, which is given in the question. So here there was a mention that the department office connectivity with the internet is critical. So that helps me to understand what is redundancy expectation. Scalability expectation is also given. The performance expectation, nowhere it is said highly available, so we are not very much bothered about that. Okay. Then we went on to select the network architecture. We selected here collapsed core campus network because the size of the network is pretty small. The total number of PCs are pretty less. Then we went on to design the network diagram for access layer design. We can choose one of the lab or one of the department, rather a sub part of a department, and you can design this access layer. Once the access layer is designed, we go to design the collapsed core architecture, and in the collapsed core architecture we are looking at the link level redundancies. In the link level redundancies is one important part here, and the device level redundancy. So how are they connected? So this is what basically we are looking at. Once this part is done, then you need to look at how to allocate the IP addresses, and the IP address allocation works. Now IP address allocation, you need to be good in subnetting and understanding the subnetting calculations. So once this is done, that's the end of how to solve a case study. Okay, and case study based questions, design questions can be a part of your examination. Thank you.